Hello everyone and welcome back to Breaking It Down with Alishba, where we take tricky maths topics and break it down to understand the why and help you understand maths better. Today we're going to be learning all about surds, what they are and how they work. Alright, let's get started. So what is a surd? It's basically a fancy math term for irrational square roots. A surd is basically a square root, a cube root, or any root really that cannot be simplified to a whole number. For instance, root 2 and root 3 cannot be simplified to a whole number, so these are surds. But if we had root 4, this can be simplified to a whole number, as we know the square root of 4 is 2. So basically, if it's a little neat number like 2 or 5, it is not a surd. But if it can only simplify to a decimal that goes on forever and ever and ever, then that right there is a surd. Alright, now that we know what surds are, let's tackle how to simplify them and understand why we do it. Let's look at a surd, root 50. We want to simplify this. Now, the best way to do this is to break it down into smaller roots. Why do we do this? Because it's easier to work with smaller roots and whole numbers when simplifying surds. Again, it just makes your life a little bit easier. Now, when simplifying a surd, you're wanting to find two numbers that multiply together to give you that number, in this case, 50. But it's really important that within those two numbers, one of them is a perfect square. And it's always very good practice to put that square at the start of your equation. So, for example, I have root 50. The two numbers I'm going to pick are root 25 times root 2. Now, if you can see here, root 25 is my perfect square, as it simplifies out to 5, whereas root 2, you guessed it, is a surd and it cannot be simplified. So root 50 simplifies to root 25 times root 2, which further simplifies to 5 root 2. And there you go. That's how you simplify a surd. But what about if we are multiplying surds? How do we do that? Well, thankfully, it's actually pretty simple. Let's say I had root 5 times root 10. All you actually have to do is multiply them. So I'll just do 5 times 10, which is root 50. Now, you guessed it, now we simplify. So we can just take root 50, and we've done this one before. So we're just going to turn it into root 25 times root 2, remembering that one of those factors have to be a perfect square, because then we can simplify it to 5 root 2. But what if we had two surds like this? Root 2 times root 9. Now, we could go ahead and just multiply these surds together and then simplify, but if you can see, we know that root 9 is a perfect square. So we can just go ahead and simplify that straight away and turn it into 3. And we know that root 2 is a surd, so we just skipped a whole step and we can go straight to the answer, which is 3 root 2. So we know how to simplify surds, we know how to multiply surds, but what about adding and subtracting surds? Well, that's when it gets a little bit more difficult. In order to add or subtract surds, the number under the root symbol have to be the same. These are called like surds. So for example, if I had 2 root 3 plus 2 root 7, I would not be able to add these as the number under the root symbol are not the same. So these are not like surds and just cannot be simplified. So this actually would be your final answer in this case. But if I had a sum like this, 2 root 3 plus root 3 plus root 3, because all my numbers under the root symbol are the same, I can add them. So I can do 2 root 3 plus root 3 plus root 3, which would be 4 root 3. But what if I had a sum like this? 4 plus 6 root 2 minus 3 root 2 minus root 25. Now off the bat you can see that we have 6 root 2 and 3 root 2, which are like surds, so I can add and take them away as much as I want. But that root 25 is going to be a problem because that's not the same as the other two. So I'm going to want to try and simplify this. Now, I don't know if you've noticed yet, but do we see something different about root 25? Is it a surd or is it a perfect square? That's right, it's a perfect square. Root 25 simplifies to 5. So my new sum is 4 plus 6 root 2 minus 3 root 2 minus 5. And now I can add and take away the like terms. So I can do 4 plus minus 5, which is minus 1. And then we want to take away both the surds. So I have 6 root 2 minus 3 root 2, which will give me 3 root 2. So my final answer is 3 root 2 minus 1. And the last thing we're going to look at is surds in a fraction form. So if I had something that looked like this, root 12 over root 6, all you're going to do is simplify the fraction, which in this case would be root 2, because 6 goes into 12 twice. And again, we have a surd here, so I cannot simplify it any further. But what if I could? Let me give you another example. We have 2 root 48 times 5 root 3 over root 12. Now, firstly, we'll look at 5 root 3. This is in simplest form. We can't really go any further than this. But we can simplify 2 root 48. So let's do it. If I have root 48, it's going to be simplified to root 16, which is my square number, and root 3, which simplifies to 4 root 3, which would turn into 2 times 4 root 3 times 5 root 3. And then we can also simplify root 12 to root 4 times root 3, which simplifies to 2 root 3. Now let's look at tidying this up a little bit because it's looking a bit messy. So I'm going to multiply the whole numbers together, which is 40, and then I'll be left with 40 times root 3 times root 3. Now I can actually cancel out one of the root 3's on both the numerator and the denominator. So I'm left with 40 times root 3 over 2. And then I can further simplify this by dividing 40 by 2, which is 20. So I'm left with 20 root 3. And that's our final answer. Okay, so we've basically covered all there is to know about surds. Now I'm going to give you guys a question that puts all of what we've learned together into one question, and I want to see if you guys can give it a go and answer it. So here it is. We've got 4 root 15 plus root 60 over 3 root 5. Pause the video and try it for yourself, and then we'll go over it together. Alright, have you given it a go? Let's do it together. Did you remember the addition and subtraction rule? Because these aren't like surds and they don't have the same number under the root symbol, we cannot add them together. But let's see if we can simplify them any further, and we might be able to add them. There's no square factor in 15, so we won't be able to simplify that any further. Let's have a look at root 60. 4 is a square number and is a factor of 60. So I'm going to use that as my first factor. Root 4 times root 15 would give us 60, which simplifies to 2 root 15. Are you seeing what I'm seeing? That's right. We now have like surds, which means we can add these ones together. So this whole equation will simplify to 6 root 15. Then the best thing to do is simplify the whole numbers and the surds separately. So I know that 3 goes into 6 2 times, and then 5 goes into 15 3 times. So my answer is 2 root 3. And that concludes today's episode. I really hope this helped you understand surds a little bit better and how and why we use them. Let me know in the comments down below if you did enjoy this and what you'd like to see next. For now, goodbye.